question of mensuration exercise 10.2. Now here you have a hemisphere is cut out from one face of cubical wooden block such that the diameter of the hemisphere is equal to the side of a cube. Okay, determine the total surface area of the remaining solid. So here given what you have a hemisphere. Okay, a hemisphere is cut out from one face of the cubical wooden block. Here you have a cube. Okay, so this cube is made up of a wooden block. You have a cubical wooden block and a hemisphere. So hemisphere is being cut out from this cubical wooden block. Then the question here is that determine the total surface area of the remaining solid. So we need the total surface area of the remaining solid. So to find this, firstly, let's solve the given question, guys. So here you have like solution. Okay. If you solve, so what's the given data over there? You have a cubical wooden block, and in this block, from one face, you have a hemisphere which is being cut out from that cubical wooden block. Okay. Now the question is find the remaining solid. So to find the remaining solid, as here we can find like the total surface area. Total surface area, let's write down it as TSA. Okay. So total surface area of remaining solid equals to total surface area of remaining solid equals to total surface area of cube. So here I am taking total surface area because total surface area wait a minute. So total surface area of cube plus curved surface area means CSA. Okay, curved surface area of hemisphere. Curved surface area of hemisphere minus area of circle. So I am taking area of circle because the base of this hemisphere, it is in the shape of circle, right? So by taking out this circle, you have a space right here, and here. So to find this space, let's use the area of circle. So where area of minus area of circle, guys. Area of over here. Area of circle. Now, so this is the formula. So now let's find the values for the given areas. Okay, well, total surface area of cube. Let's find the total surface area of cube firstly. So here, where TSA mean total surface area. Let me write it like total surface area of a cube. Area of cube equals to, as we know our formula for total surface area of a cube equals to 6a square, right? So total surface area of cube equals to 6a square. Then here, okay, just look into this point where the diameter of the hemisphere is equal to the side of the cube, guys. Means the diameter of hemisphere is equal to the side of the cube. So now here, let's consider like, I can say like where diameter, right? So let me write down here where diameter of hemisphere is equal to side. Okay, it is equal to the side of the cube. So here, if so diameter of hemisphere equals to side of the cube. So they haven't given any diameter value. So but they have given what diameter of hemisphere equals to side of the cube. Let side of the cube be A. So now let's find out, like I got total surface area of cube, but total surface area of cube equals to 6a square. Okay, let us keep this aside. Now here let side of the cube. Let side of the cube be A. Okay, let side of the cube be A, guys. Okay, now here if side of the cube is A, then the diameter of hemisphere will also be A, right? If side of the cube is A, then the diameter of hemisphere will also be A, as here I can say, right, where diameter of hemisphere, where diameter of hemisphere equals to A, then the radius of hemisphere will be what? So let me write down like radius over here, where radius usually represented by what? R. So radius R equals to D by 2, diameter by 2, where diameter equals to A, so I can write like A by 2, okay? Where radius equals to A by 2 and diameter of hemisphere equals to A. So here I got what? Radius equals to A by 2. Now here you have curved surface area of hemisphere. Okay, so CSA of hemisphere formula is what? Now just substitute this value in this curved surface area of hemisphere. So let me write down like. Okay. So C curved surface area of hemisphere. Okay, curved surface area of hemisphere formula will be 2 pi r square, guys. Okay, so curved surface area of hemisphere is equals to 2 pi r square. So here 2 pi r square, 2 value I know and pi value as well 22 by 7, but in this given question let pi value be pi. Okay, now next you have r, where r equals to A by 2. Radius I have taken like A by 2. R value, radius value A by 2. Now just substitute this value like here. We got what? Where radius R, radius equals to A by 2, right? So now just substitute like 2 into pi value, let pi be pi value be pi. Okay, now r square means radius square, r into r. So radius is A by 2 into A by 2, right? So here 2 times 1, 2 ones 2, 2 ones 2, right? So 2 ones are 2 gets cancelled, and now here you have is 2 over here, let 2 be 2. Now pi value A into A square, right? A into A, here A. So A into A gives what? A square. Therefore I got what? The curved surface area of the hemisphere is pi a square by 2. Where curved surface area of hemisphere, let me write down over here, where TSA of cube, where TSA of cube equals to 6a square, and CSA of hemisphere we got now what? CSA of hemisphere equals to pi a square by 2. Now let's go for the next one, where area of circle. So area of circle formula is, okay, let me write down over here. Area of circle, let's find out the area of circle, where area of circle equals to pi r square. Okay, area of circle equals to what? Pi r square. So let pi be pi. Okay, let pi value be pi. Now here just write down like pi into r means A by 2 into A by 2. Right? So 2 times 2 is 4 as we know. So 4. Now pi value, let pi be pi. A into A square. Right? So therefore I got what? The area of circle. So area of circle equals to pi a square by 4. So we got all the values. Now just substitute like where. Now here substitute these values. So by adding like you have total surface area of cube. So this becomes what is total surface area of cube equals to 6a square. So 6a square plus 6a square plus curved surface area of hemisphere pi a square by 2 minus you have area of circle. So minus area of circle. So area of circle is pi a square by 4. Pi a square by 4. Now here if we further simplify this equation, so this gets like 6a square plus, if you take LCM for 2 and 4, this gives what? 4. LCM for 2 and 4 gives 4. So LCM into numerator by denominator. If we do like this, where LCM into numerator gives so LCM into numerator by denominator, this gives 2 pi a square minus again over here pi a square. Okay. So 6a square plus 2 pi a square minus pi a square by 4. Done. Now here just focus on this, where 2 pi a square minus pi a square. Well, imagine 1 over here, guys. So 2 minus 1, 1. So I get like, if I write like this, I can write like 6a square plus 2 pi a square minus pi a square gives what is pi a square again. So pi a square by 4 as it is. Now here, let me further write down here over here. So if I write here, well, I got what? 6a square plus pi a square by 4. Now take a square as common. Take out a square as common, as we get like a square okay, a square into 6 plus pi by 4. Then a square into 6 plus pi by 4. Therefore, I can conclude like therefore, let me write down here, therefore, the total surface area of the remaining solid is a square into 6 plus pi by 4. So, if we write like TSA, total surface area of remaining solid is a square into 6 plus pi by 4. So this will be the final answer.